Hello everyone and welcome to our universe. Today we'll be talking about the classification of galaxies. So there are obviously a lot of galaxies in our universe, but how exactly do we understand them, and can we put them into quite an ordered state? This is where the classification of galaxies comes into play. It all started in 1924, when astronomer Edwin Hubble proved that galaxies are very distant objects that each contain millions or billions of stars bound together by gravity. Within a few years, he set up a system to classify these galaxies, and we still pretty much use the same classification to this day, with some modifications and additions. So the Hubble system is basically divided into three categories. We've got the elliptical galaxies, which are relatively featureless spherical. The other one is the spiral galaxies, and these have very distinctive arms that spiral out from their centers. And finally, we have the irregular galaxies. This is basically any other galaxy that doesn't seem to fit into the ellipticals or spirals. So elliptical galaxies are marked with the letter E, and these galaxies can be subdivided depending on how round they appear. So therefore, a number is added to the E from 0 to 7. A completely round elliptical galaxy is known as E0, and a more flattened galaxy, but still has round features, is known as an E7 galaxy. So these are the two extremes of elliptical galaxies. Spiral galaxies, on the other hand, are divided into two main types: regular spirals, which are denoted with the letter S, and the barred spiral galaxies, which are marked SB. The regular spirals basically have arms that spiral inwards into the galactic center, whereas the barred spirals seem to have a bar shape in the center, and from this the arms seem to extend out. About 2/3 of all spiral galaxies have some kind of bar, and of course our Milky Way galaxy could as well be a barred spiral galaxy. Astronomers have seen a bar-like structure in the galactic center. Both regular and barred spiral galaxies are basically defined by a spherical bulge of stars at their center, and this is then surrounded by a thin rotating disk of stars that contain many spiral arms. And just like the ellipticals, the spiral galaxies, both regular and barred spirals, are subdivided into more categories. This depends on how tightly wound the spiral arms are. In SA galaxies, the spiral arms are tightly wound around the central bulge, whereas the SC galaxies have arms that are quite loose around the central bulge, and therefore are less prominent. The barred spiral galaxies are known as SBA, SBB, and SBC, and these are basically put in the same type of category, but these are just simply galaxies with a central bar. Irregular galaxies have no subdivisions. These are basically galaxies that have the characteristics of spirals and ellipticals. These basically show a large central bulge and a disk, but have no obvious dust lanes or spiral structure. Galaxies, of course, come in all shapes and sizes, and it is very hard to tell how large a galaxy is based solely on its photograph. For example, a very large galaxy that is also very distant can look the same size as a much smaller galaxy that is very nearby. So therefore, you have to know a galaxy's distance to know the galaxy's size. The Milky Way is a large barred spiral galaxy, but there are many galaxies that are much larger, and there are also many galaxies that are a lot smaller. As for the most common galaxies in the universe, astronomers think that they are tiny faint galaxies called dwarf galaxies. The combined mass of all these dwarf galaxies in the known universe exceeds the mass of all the large galaxies taken together. The Hubble classification is based solely on how a galaxy looks. This classification is still used today, because there is a correlation between the physical differences and the different types of galaxies. Elliptical galaxies contain many old stars, and have very little gas and dust found between these stars. From our understanding, new stars seem to form from clouds of interstellar gas and dust. Elliptical galaxies lack these raw ingredients to make new stars, so elliptical galaxies can be defined as a sort of dying galaxy. Spiral galaxies, on the other hand, have a mix between young and old stars. This is because it has a lot of gas and dust that fill the disk of the spiral galaxy. The disk formation is the main source of new star formation. These seem to have the rich ingredients of continuously creating new stars, so the spiral galaxies can be known as the younger and fresher galaxies. Irregular galaxies are simply more chaotic. They can often be very bright, they can have young stars, and therefore they have recent bursts of star formation. But again, irregular galaxies can just be known as a galaxy that isn't quite spiral, but isn't quite elliptical. This classification also gives us a great insight into how the galaxies formed. For many years, astronomers basically thought that a galaxy looked that way simply because they were born that way. Astronomers have now learnt that galaxies can change their appearance over time. This is usually a result of interactions, collisions, and mergers between galaxies. These interactions between galaxies cause great star formation. They also evolve the shape and characteristics of the galaxies themselves, and this is known as galactic evolution. Galactic evolution can turn one type of galaxy into another type. Mergers and collisions often stimulate these bursts of star formation, and as a result, many irregular galaxies are thought to be a result of galactic interactions. These collisions alter the overall appearance of galaxies. But even though these galaxies are merging together, the stars themselves will not collide, but they can change their galactic orbits. This is like merging two oceans together and expecting two ships to hit each other. The chances of it happening is basically zero. Over the years, the Hubble classification has had modifications and additions to it. One of these modifications considers whether arms spiral outward from a ring of stars, and other additions consider a spiral galaxy's total brightness, instead of just how they look. These changes allow astronomers to know a lot more about the properties of galaxies, and how they were created, how they evolve, and how they will eventually die. Future astronomers will of course make additional changes to the Hubble classification, and this will give us a great understanding to how galaxies play an important part of the evolution of our universe. So, I hope that's given you a great insight into the classification of galaxies. And of course, if you want to know any more about galaxies or the Hubble classification, I'll put some links in the description below. And as always, if you've enjoyed the video, click the like button, and if you want to support the channel, click subscribe and support our Patreon page. Thank you for watching, and thank you for your support.